Hey everyone, I'm Gwen from Nile, and today I want to show you how I built an AI-based software as a service product. An example one. I call it Code Assistant because it can help me learn a new code base. So the idea behind what I built is that I can have the AI learn a code base, and I'll show you how AI can learn a specific code base. So for example, I can take one of Nile's example code bases, like the NextJS quick start. And as you know, one of the things that happen when you go to a new code base, you ask yourself, where does it access the database? How does it handle errors? How does it handle logins? Like you just try to orient in the code. So we have a bunch of those built-in questions. And we can also ask our own. Where does it access? Where does it access the database, for example? And then the AI searches through the code base and comes up with some places where it accesses the database. And it says here, the code snippets add to do and complete to do access the database. This is, by the way, 100% correct. And they interact with database with the tenant Nile DB query method. So it actually finds you the files where you have to look, and it even directs you to the specific methods that you need to check out. And it's all over here. You can browse the relevant parts of the code. The nice thing about this example is that every tenant ingests whatever repository it wants. So it teaches the AI about its own code base. And if some of this code is, for example, private, you can still do it safely because Nile has virtual tenant databases. We isolate code snippets that we use to train the AI model or to argument the AI model. So if I ask, hey, how does my code access the database? I will get an answer about my code. I'm not going to get an answer about someone else's code, which is both important, so I'll get the answer I want, and also important for you to know that nobody will learn about your code because they happen to be using the same AI. So this is the example. I'm going to explain how I built it. And I'm going to start by explaining the architecture behind it. This example uses what is known as RAG, Retrieval Augmented Generation architecture. So I'm going to give you some overview about that. And then I'm going to start bottom up. So I'm going to start by showing you how I designed the database and how I created different data structures. We're going to talk a bit about PG Vector. And then we'll go one level up and show you how we use PG Vector in Next.js code. So we can index the repositories and then pull out relevant snippets. And then how do we tie it together with the OpenAI model that we used? We used the 4.0 mini here, so we'll show you how to do this interaction using the OpenAI client. And then we're going to go even one letter up. When you showed you the answer, did you see how it gave the response kind of letter by letter? It looks like it's a streaming response, it looks like it's just typing it out. This is pretty cool, and I'll show you how we did this streaming effect as well. So a lot to talk about. Let's get started. First things first, RAG architecture. So the code assist is built on RAG, which is Retrieval Augmented Generation, which means that I'm using something, I'll tell you in a second what, to search the code for the most relevant parts. And then when I go to the AI, I don't just ask, how does this code access the database? I don't try to give it an entire repository, which is A, expensive, and B, not going to give you very good results. Instead, I say, hey, here are some code snippets that are very relevant from a project. Now, please tell me how does it access the database. And if I give really good code snippets, I'm going to get a really good answer. If the code snippets are crappy, I'm going to get a crappy answer. So it's really important to be able to give good code snippets. And how do I know which code snippets are relevant to my question? There's a lot of ways to. All of RAG is based on the idea that you should be able to find relevant code snippets. There is a lot of ways to do it. You can do text search. So does it have similar keywords? Is one way. There are some kinds of graph similarities that kind of show concepts and the distance between them based on graph algorithms. We're using vector embeddings, and we're using what is known as semantic similarity. And the idea is that you use a large language model to code the semantic meaning of sentences or code in vectors. And then the distance between vectors indicates how similar those things are. And there are several distance algorithms, and we are going to show you how to use it in practice. We're using OpenAI's text model to encode our code and the question. And then we're going to use pgvector to both efficiently store the data in our Postgres database. We're using Nile, of course. And we're going to also use pgvector to find, given a question, which bits of code are the most relevant, most similar to this question. So, in order to do that, I kind of hinted at it, but I want to be explicit. There is two parts to a good RAG flow. There is the ingestion pass, which is, here is a bunch of documents, please encode them in vectors and store them. And then there is the Q&A pass, which is, here is a question, find some similar documents, give them back to me. Sometimes they are both part of your application. You probably know some cases where it's like, I'm giving you a PDF, please answer my questions based on snippets from this PDF. So you have to first learn the PDF I gave you, encode it, and then start answering my questions. The other flow is that it's completely separate operations. One person encodes a lot of documents. You can imagine that there is a process for encoding like support knowledge base document. And then when a customer shows up and asks questions and those documents are retrieved, it's just a completely separate application. In this example, I separated things. I have a script for ingesting code repositories, and then I have the application which only answers questions. It does not ingest anything new. Okay, I think with that you learned all the basics. So let's get started into how we build it. And like any good application, we start with the data model. So let's take a look at the tables we're going to need here. And of course, to create the tables, I'm going to need a database. So let me log into Nile. And I have a database. And you know what? It's actually an empty database. So I'm going to use this one. You can see I only have the tenants table for my future customers, but I did not create anything yet. So this would be a good time. And I'm going to start with creating a table for my embeddings. And embeddings are the vectors that I mentioned earlier that encode the meaning of each sentence. So let me paste that here. Now, few things you want to watch out for. First of all, the name of this table. You can see that I actually put the name of the model in the name of the table. Why is that? Because embeddings are specific to the model. If I have a different model, I need to re-embed existing data. All those vectors are useless if I now start embedding questions with a totally new model. So I want to separate that. And why not just have a column with model identifier in here? The other thing is that the size of the vector is really important. And it has to match the size of the output of the model. Now, some models can give you output of pretty much any size. OpenAI's text-3 large or small is one of them. Some models will give you just one size or will have a set of 3 different sizes to choose from. But if you have a model that only works in one size, do not try to truncate the vector yourself because you don't know if you're losing important information or unimportant information. There are techniques to do it. It's not impossible to do it yourself, but you don't just go off and chop bits. There is more to it. The other thing is that you can say, okay, I'll create a really big column and just everything is going to fit there. If I put like 8K, everything will fit there. 3 reasons not to do it. A, due to Postgres, you'll get way better performance if every row fits database block. Database blocks are 8K, there is some overhead. Those vectors, when I say 1024, it's 1024 floats. So each one of them is 4 bytes. So you have to do the math, definitely not 2000. So this is one reason to try to stick to models that are relatively small. There is also no relation between how big the vector is and how good performance you get. If you look at model benchmarks, some of the best models that are way up there are 256, 768, they don't really, and then you have very low rankings that are like 8,000. Bigger is not necessarily better in this case. Also, if it's too large, it doesn't fit in one database block, you will not be able to index it. Nice folks in pgvector are working on a solution, but don't do it at this point. The third thing is that insert into of a vector to a column have to be exact. And this bit is important. You'd think that a small vector will fit great into a big column, but no, it cannot be too large, it cannot be small. The only thing that will get into a 124 dimension vector column is a 124 dimension vector. So otherwise you'll get errors. So this is an important bit, which means that when you switch models or when you play with sizes and so on, you will likely want new tables and you likely want to re-embed all your existing documents. Okay, let's run this thing finally. Oh, and one more thing for you to notice is that I have a tenant ID column. This makes the table tenant aware, which means that it's split between the virtual tenant databases. So when I connect into a virtual tenant database and try to look for similar vectors for a specific tenant, I'm going to get just data for this tenant. I will never leak data from another tenant. That's also important. Okay, typos aside, we have the table. Now, embedding is not enough. I actually want to store the content of the code files themselves in this repository. Why do I want to do that? Because if I store both the text and the vector in the same database, and I can actually do a join between them, it means that I can, if I look for the 3 closest documents, I can return the documents themselves in the same query. So I don't just return here are the IDs of the 3 nearest documents, I return here are the 3 nearest documents, which means that I don't need to do any additional API calls to get the document. I don't have to worry about, oh, the document actually changed, someone did a large merge and reorganized everything while I wasn't looking. Like, I get the exact documents that I embedded in one single database call, much faster than just doing tons of API back and forth to S3 or to GitHub and dealing with their authentication and all that. So let's create a table for the content of the files as well. And we have that. And then we want some metadata information because every tenant has several repositories with different projects. I want to create a table with some metadata, like the GitHub URL where I got it, and maybe some name, description, the usual. Just because we're dealing with cool AI stuff doesn't mean we get a pass from the boring metadata, which is kind of what makes Postgres a good place to store your vectors, because it stores the vectors, but then it stores all the other stuff that you're going to need for the application as well. So it's just super convenient for me. So we have all this in place. You can see all the tables got created. And now before we leave the dashboard and go play with our application, we are going to need to grab credentials. I already have some credentials, but of course I didn't save them. Don't make my mistake. Generate credentials. We're copying them. If you don't copy them, you're going to make my mistake and you're not going to remember what they are, and you'll need to create a new pair. We never tell you what your password is. For obvious reasons, we don't store it. Because it's a username password that gives you access to your new database, make sure you keep them safe. If you accidentally leak them, someone else will be able to access your database. So keep them in a safe place, don't lose them, and don't give them away. Okay, so now that we're done with security license, one more thing you have to do. You have to get credentials that give you access to both an embedding model and an AI model. So in this example, I use OpenAI, but you have tons of alternatives. Amazon and Google and Grok and Fireworks and Cohere. Like everyone and their mother these days are hosting models. Find one that fits your budget, and the APIs are very similar. So again, I used OpenAI. There is a lot of vendors that are just compatible with the OpenAI client, and you can pick whatever. Okay, so hopefully you got your credentials in place. Now it's time for us to go and run the example. And we're going to use npx create next app to create a copy of this application locally. So we can run it and study it and so on. Okay, so we have our code assist, and next thing we need to do before we try running it is actually set up the environment. So we're going to create an env file, and because it's NextJS, it's going to be env local. Okay, so let's start filling this in. First thing, I need the username. So I'm going to basically grab what I copied a second ago. But the important bit is this one. And don't look. Okay, so I saved the file with all my configuration. And now it's time to start the application. Oh, before that, I need to generate embeddings. So let me show you how we generate embeddings. Okay, so you can see that I basically did git clone and got a lot of examples basically onto my local disk. And then for each one of them, I just say embed directory and give it some metadata. And that's it. So let's take a look at the actual embed directory. So the embed directory just creates the project in database, but then it calls process files to actually do the embedding. And you can see that there is a bunch of files that we are ignoring because they're not all that interesting. And one interesting bit is that irrelevant files may accidentally end up looking similar because, node modules have all kinds of terminology in there. For example, you definitely don't want random stuff getting embedded because then you may get random stuff as a result for queries that may appear similar. And then you give it to the AI and you get a totally random response. So the interesting bit here, it's all being done in a single transaction. So you can see the begin here. I'm starting a transaction. I'm reading the file content. I'm putting it in the database. And then I call create vector embedding, which we'll look at in a second. And we also insert the embedding into its own table. And then if it all worked well, we commit. If it didn't, we roll back. This means that we either insert the data and the embedding or neither of them, which is another great reason to use a relational database like Postgres to store vector embeddings. That you don't end up with just unsynchronized, missing half examples. Okay, I found the nearest embedding, but hey, where's the file? Who knows? It's not there. So we make sure to do everything transaction. I'll show you how the create vector embeddings, what it looks like in a second. But first, let's actually run it and get the embeddings. Okay. And you can see that it is now embedding a lot of files. Oh, something I forgot to mention is that if you are interested in trying to embed your own repositories, you can obviously edit the embedder script or repo embedder and put whatever you want there, whatever repository, whatever code base you're interested in. You can edit in and start querying it. Okay, and I think we're done here. So now that we have the embeddings, we can actually run the application. Okay, I need to sign up since it's a brand new database. Okay, and since I signed up, I can see all the tenants that I ingested. This is part of the code. Usually when you first sign up, you don't see any tenant, you're supposed to create them, but this is a demo and I wanted everyone who signs up to the demo to be able to browse some pre-existing repositories. So you can see all those fake tenants here that you can browse, and then you can pick one. And you can ask it, how does the project handle errors? It's a good question about Llama Index chat. I have no idea how Llama Index handles errors. And you can see that it has an error boundary component, and it has a card that displays the error, and a lot of really good JavaScript best practices. So it even cleans the data on error, and you can actually see the code where it's doing it. As this is the code that we pulled out as the most similar parts of the code for this question. So you can see that we highlighted the right bits. So now that we got it working locally and we embedded a bunch of documents and we did the question and answer flow, first of all, we can see the embeddings and the code in the database. You can see that in file content, if I just get some files, you can see the URL and you can see a bunch of the content, like here's what the code looks like. And then same thing for the embedding, except that looking at embeddings is probably the most boring thing in the world because you're looking at lists of 1,024 numbers. Now that we understand that, let's take a look at some of the code highlights so you can learn how it works. Okay, so first of all, perhaps you remember when I showed you the code that inserted the embeddings, I said, hey, we have create vector embedding here, right? We insert the file content to one table, then we call some AI model to give us embeddings, and then we insert it onto another table. So I put it in embedding utils. And the idea is that you wrap the call to the model with your own API. And the reason you want to do it is that while mostly models have the same API, there are tiny differences. So if you call OpenAI, it returns an array and you can get the result in just as the first item in the array. Others return an object that has an array in it. Others return an array that has objects in it, so you actually need to pull stuff out of the object. There is a lot of different ways to return what is essentially an array of 1,024 numbers. You want to localize this variance in case you need to switch models. You localize this variance into one method. The rest of your application just calls create vector embedding. It always gets a promise with a vector. When you finish waiting for it, you get the array with numbers. What goes in is a string, and everything else is contained here. We basically import OpenAI. I'm using LangChain here, but the actual OpenAI client is extremely similar. You create this AI object, you say watch model, you say how many dimensions, there's sometimes other options as well. And then you tell it, please embed documents, give it the document, and wait for the embedding. That's it. So we now know how to take a bunch of files, generate embeddings, put the files and the embedding in the database. Let's move to the fun stuff, having a conversation with an AI. I put all the logic for this behind one handler endpoint, which is embed query. And then we're taking the question that the user asked, and we say create vector embedding. Exactly the same create vector embedding that we just used a second ago. We get embedding, we do some formatting so you can actually use it in a SQL query. And then we build a query. What does the query do? Go to the embeddings table and find everything that is in for this tenant in this project. I don't have to specify tenant ID because I connected to this virtual tenant database for this specific tenant. So, but I say, okay, take everything, order by how close they are to the question, and bring me the top 5. So top 5 code snippets that are the most similar to the questions that the user just asked, the most relevant. And then I'm pulling the file ID, the file name, the contents of the file, because I'm doing a join with file contents. And I'm also pulling in a bunch of different distances. I note that I'm only using the inner product for sorting, but pgvector supports a lot of different distance metrics, and different models have different preferences. So everyone supports cost and distance, but some models are normalized and they will give you basically the same result if you use inner product, and inner product is much faster to calculate. So we're using inner product here, but for testing and just to validate that I'm doing something sane, I actually pulled in the numbers from all of them, just so I can eyeball and say, okay, those are actually relevant and they didn't get some ridiculous score. Something I didn't do here, but I probably should have, is something like making sure that the distance is actually sane. So, for example, smaller than 1, because after that it's already too irrelevant. So you kind of want to filter by what is relevant, because sometimes the closest, if the data is really, really bad, the closest embedding is still going to be kind of irrelevant. So you want to really at some point filter by the relevancy score as well. Anyway, I got all the files and now I'm logging everything so I can actually double check myself. This is a good practice to actually log the results from what did I retrieve? And as a human, you actually can take a look and say, this is relevant. This is BS. Oh, it actually did not find the most relevant document that I have in the database. Why did it not find it? What's going on? You can catch a lot of bugs just by eyeballing and double checking with your human intelligence what the artificial intelligence is doing. And I caught just stupid bugs like I'm sorting in the wrong direction that way. Okay, and then I'm still using OpenAI, but this time it's a different API because I'm not asking for an embedding. I'm asking for a chat. I am actually missing model here. And I'm asking for a chat. And then I am calling the model that I just instantiated and giving it a prompt. Everyone loves prompt engineering. So you can see I'm saying you're a principal software engineer, you're talking to another software engineers, we want to see code snippets, you're getting here's some relevant code snippets for you, please use them and please include them in the answer when they're relevant. And it turns out when you say things like you're a software engineer talking to other software engineers, you get more technical responses than when you say things like you're a helpful assistant. So this is really weird and really fascinating to play with. So we did that. And then we get an answer. And at this point, I have the answer. I can just display it. And in previous iterations of this example, I just sent JSON object with the answer and the relevant files up to my UI, and the UI display the answer and display the file, and all was well. But I don't want to just get a complete answer and then send a JSON with a complete answer and display a complete answer. I want it to be streaming. So now I'm going to show you how I'm doing a streaming response. If you're not at all curious about how to actually show a response in the UI, this is a good place to skip to the end where I tell you goodbye and discuss next steps. But if you are curious, it is kind of interesting. So we're getting a streaming response, meaning chunk by chunk, block by block. Every time I read out of the response stream, I am getting more information. And we need to, every time we get something out of the response stream, to send it from the UI, and the UI has to update and just keep on appending to the answer. So I am basically going to start iterating over this stream. Resprim stream is a JavaScript iterator, and over up here, I'm basically taking this iterator and I'm starting to send it chunk by chunk up to my browser. And I'm using the readable stream API. This is part of the JavaScript standard. I'm starting the controller, and the first thing I'm doing is in the controller shoving in all the stuff that I already have for sure, which is the list of relevant files. I already have them because I sent them to the model, and the content of those files. I can send it back and just display it right away. So I'm doing it right away. And then I'm saying, okay, I'm done with the JSON. I'm done with the parts that you can just display right away. Now I'm starting to stream. The UI is asking for more data. It's pulling more. The readable streams that I have here is calling iterator next. And if there is any data, we're putting the data in the queue to send it back to the client. Once we're done, we're closing the whole thing off. Not super simple, but not rocket science. The one thing to pay attention to is the fact that I almost invented my own protocol. Like I have a JSON part, and I have an end of JSON marker, and then I have streaming data, and I need to make sure that my UI knows what to do with it. So if I go to my chat component, here we go. We have the fetch here. So I'm basically sending over the question. And then I need to do something with the response. And I need a reader because I don't have all the response at once. I need a reader so I can iterate over it. And I need a bunch of markers to know when did I get what data, and did I get the list of files yet? Did I get the end of JSON? Am I done? And so on. So basically there's two parts to it. Before I got the initial JSON with the list of files, I'm just iterating, adding data, looking for them until I get end of JSON. Once I get end of JSON, it means that I get the second data part. I can start sending it over to the UI, and then every response after that, I can keep on appending it to the chunk. And in order to append parts of the response to the chunk, I'm calling dispatch. And dispatch is, of course, JavaScript and React. And the idea is that I'm using a reducer, which allows me to update a data structure. And because it's React and it's cool, it updates the UI as the data structure updates. And my data structure has two different actions. I can add a question, or I can update the answer and keep on appending to the answer. And then there's stuff to do when you're done, but that's not interesting. Well, when I append a question, I basically post the question, and then I have an empty answer. And then as I get the answer, I keep on updating the array. The answers that I want to update is always the last entry in the array. But because I'm updating an entry in the array, and I need React to know that the array has changed, I have to actually keep copying the array, which, if you're going to have a lengthy conversation, may be a bit annoying. But if I just append to the same cell in the array, React will just think that I didn't do anything, which is not very useful. You can see where I'm displaying the array over here. I'm doing some treatment to make sure that if any code snippets have to show nicely. Yeah. So this is where I'm showing my message, and you can see up here that the array of messages is tied to the reducer, which is tied to the dispatch function that can update it. So it all comes together. I have an array with messages that I know how to display. I have a function that knows how to update it, and as I'm getting more responses, I call this function to update. It updates the array, and the array gets displayed, and you can kind of see the data showing up. Okay, that was a long one. Maybe the longest tutorial that I've recorded. If we look way back, I briefly explained what is RAG architecture. I have another video with AI concepts where I explain the architecture in more detail. You can think of this as a small refresher and then a lot of hands-on implementation details. After that, I showed you my data model and I explained why I model things the way I model them. I showed you how to index a bunch of code repositories, and it turned out to be fairly straightforward. Like in any case of data ingest, anything you can do to give the data higher quality, filter out irrelevant part, chunk it in a better way, all of those are going to improve your results. Then, after we learned how to index, we also learned how to pull out data. We learned how to pull out the 5 nearest documents with their content in a single database call, which I think is pretty nifty. Then we use that to have a small conversation with a larger model. Small conversation and with a larger model. And which I showed you, for those interested in such things, how to stream the response to the UI. So I hope parts of it was useful. As next steps, you probably want to clone the example yourself, index some of your own repositories, play around with it, maybe improve things. I decided to include a README. You may think that the README is actually reducing the quality and you want to leave it out. You can play around with that. You can definitely play with the prompt. You can play with different models, different vendors, a lot of stuff to play with. If you want different examples, Nile has a large list of examples that we're constantly adding to. We also have ideas for projects that we did not implement. If you want to build the world's smartest chat, the world's smartest human resource application, we really believe that every SaaS can get disrupted by a smarter SaaS. And if you have a domain that you're an expert in, playing with how AI, especially with RAG, which is a more grounded, less hallucinatory AI because you actually provide it with the information it needs to give the correct answers, well, the world is your oyster. It has never been a better time to play around and build AI native software as a service. So I hope you'll play around and let us know how it goes. As you know, Nile has Discord, we have GitHub, I'm on Twitter, and we're going to post a lot more videos, both on AI and other Postgres topics and other SaaS-related topics. You can like and subscribe and get more videos as I publish them. Have great learning experience.